In this lesson, we're going to talk a little bit about why ACI is built on a spine leaf architecture and what that encompasses. As we talked in previous lessons, the data center architectures are changing. The way that devices communicate on the network has changed over time too. It used to be 80% north to south communication between client and server and 20% between servers and other servers on the network. And today it's actually 80% server to server communication inside of your data center and 20% between client and server. We have applications like VDI that are sitting in our data center where users are sitting right next to the servers. We have applications like SAP and HANA, and we have applications like Hadoop where servers need to talk to servers in a very low latency, very fast, very highly available way. And that's why ACI is built on this spine leaf architecture. Let's take a look at what that entails. As you can see, in a spine leaf architecture, we have the spines that connect to the leaves and the leaves that connect to the spines. Spines do not connect to each other and leaves do not connect to each other. Only the spines connect to the leaves, and all of the traffic enters and exits the network through the leaves. So as you connect this to your traditional network, you will connect the traditional network to your leaves, as well as the servers that you connect to the network and any layer 4 through 7 services. The leaves provide high-speed, non-blocking access to the servers and the devices through 10 and 40 gig, and they provide the high-speed, non-blocking fabric connectivity of 40 and 100 gig on the fabric. So you can see that any server can talk to any other service or server inside the fabric at very high speeds across the fabric. It's very high performance and low latency for east to west traffic, and it's only a maximum of 2 hops to get to any other device. So it actually reduces complexity inside of that environment. The other thing is that all the devices at the top of the rack can actually be gateways. So I get redundant gateways at the top of the rack, as well as the fact that those leaves can do layer 3 routing and layer 2 switching right at the leaf. And we can also push that functionality down into the hypervisor if you're in a virtualized environment. The fabric itself actually runs in a very highly available and scalable way by getting rid of spanning tree inside of our environment. A lot of our applications require layer 2 connectivity across our entire environment. And when you use spanning tree, you actually add risk to your environment while also adding that extra capability. With the ACI fabric, we're actually running a layer 3 protocol underneath called ISIS, as well as VXLAN on top of that as an overlay to provide the layer 2 functionality. On top of that, we also run our multi-protocol BGP. And multi-protocol BGP basically acts like the control plane protocol across the fabric to share information so that we don't have to do it in a flood and learn manner, which is much more efficient. This fabric is built for connectivity of both physical and virtual devices that can connect to any leaf at a high-speed, non-blocking connectivity. The fabric itself is built to be very scalable and redundant. If I want more capacity, I simply add another leaf. And through our zero-touch provisioning, I basically can cable it up and it will be automatically discovered through the fabric as we cover in additional lessons. I can also add more spines if I want more bandwidth or more resiliency. For example, with 2 spines, if I lose one of the spines, I lose 50% of my bandwidth. If I add 4 spines and I lose 1 spine, then I lose 25% of my bandwidth if I was to lose a spine. And statistically, the chance of me losing all 4 spines is much less than if I only had 2 in my environment. This spine leaf fabric is actually managed as a fabric or as one entity, where we see all the health of all the spines and all the leaves across the environment. And I manage this all through a controller, so I get away from managing individual devices on my network and can concentrate on my network as a whole. I also have the capability of what we call a whitelist fabric with this spine leaf architecture, where the whole fabric can basically act like a layer 4 firewall. I can define these security policies and apply them across my entire infrastructure, whether that's a physical or virtual device, or whether that's a VMware, a Microsoft, or an OpenStack device. The other thing that I wanted to mention is that while our spine leaf architecture is different and new, we actually don't replace our core inside of our environment. This spine leaf architecture normally just takes the place of the access or aggregation layer. So once again, all my devices at the top of the rack would connect to a leaf, and my leafs would connect to my spines. But because everything enters and exits the network through my leaves, my normal infrastructure, like my data center core, would also attach to my leaves. And in this case, those leaves would be called border leaves because they have the specific function of being a gateway to the rest of the network. Now that we know some of the physical architecture of the network, let's examine the role of the APIC controller in Lesson 8.3.